This transformation is called a half line. If you have a transformation that looks like argument of a complex number z equals to some angle alpha, that means that you have a line that starts from the origin O and goes straight, and that is going to make a horizontal angle alpha. Now in this case it's an x-axis, but it doesn't really matter, it is going to be a horizontal line. So if you have an example, argument of z equals to pi by 3, that means you have this axis and this axis. So this is going to be, remember, this is not x or y, this is real imaginary, it's an Argand diagram. So it is going to be this line and it's going to make an angle of pi by 3. Another version of this is argument of z minus a1 plus I b1 equals to some angle alpha. In this case, the starting point is not going to be the origin O, it's going to be the point A1, B1. Doesn't matter where it is, it's going to be like this. This point is A1, B1, and the angle is going to be any horizontal line with it. So this is going to be alpha, and this point is going to be A1, B1. Let's do an example. Suppose you have argument of z minus 2 plus I, and this is equals to pi by 6. So the first thing we have to do, we have to find the starting point. So this is 2 plus I is 2 comma 1. So if this is 2 and this is 1, this point is 2 1, and it will be a line like this, and draw a horizontal line over here, and this is pi by 6. That's it, that is the transformation. So let's do another example. So argument of x plus 3 minus 5I equals to pi by 2. Now first of all, the format is z minus, so we have to rearrange it. So we have to write it as minus, so this is going to be minus 3 plus 5I, so that if you open the bracket it becomes plus 3 minus 5I, and this is equals to pi by 2. So the starting point is going to be minus 3 5. So it's going to be, so x is minus 3, y is 5, so this point is going to be minus 3 5, and it is 90 degrees, so it is going to make an angle of 90 degree with the horizontal line. So 90 degree means completely vertical, so this is 90 degree, and that is the transformation. Here is another one. Argument of z plus 2 plus 2I equals to minus pi by 4. First of all, let's find the starting point of the half line. It is going to be z minus, since it's, has to be negative. This will be minus 2 minus 2I, so minus pi by 4. So it is going to be, so minus 2 is going to be the starting of the point, minus 2 minus 2. So this is the point, minus 2 minus 2. And the horizontal line, the angle is going to be minus pi by 4. That means it is going to be in the, clockwise direction. So minus pi by 4 is going to be this angle. So this is going to be minus pi by 4. If it was plus pi by 4, the angle would be in this direction, but that is plus pi by 4. So remember, negative means in the clockwise direction and positive means in the anti-clockwise direction. That's how it works. Now there is another version of this argument transformation, and it is, if you have argument of, suppose, z1 divided by z2, and you have some angle, suppose alpha, in that case what happens, you write it as argument of z1 minus argument of z2, and you draw two half lines. Let me give you an example over here. So example, so we have argument of z by z plus 3 equals to pi by 4. So we break this down into two sums. So argument of z minus argument of z plus 3 equals to pi by 4. That means if you write argument of z, this is going to be z minus 0 plus I0. Basically it means it's going to start from the origin, minus argument of z minus minus 3 plus 0I, and that is equals to pi by 4. So if you multiply, this is going to be z plus 3, and so the points are going to be, this is going to be the origin and this is going to be minus 3 0. So let's draw this. So here we have one half line as here starting from the origin, and we just draw a line like this, and then we have another line that starts from minus 3 0. So if this is minus 3, then this is 0, and we draw another line, and we let the two lines intersect, and the point where they intersect, that is going to be pi by 4. Now the question is, how do you know that the pi by 4 angle is going to be over here, it could be somewhere else? Well, for that you need to review the concept of circle, angle subtended by a circle. Suppose if this is circle and there is an arc, or you can consider this to be a chord, an angle subtended at the circumference, they're all equal. So all the angles subtended at the circumference, they are all equal. So what's happening over here, you have to think of this as a circle, and this is the angle being subtended at the circumference. So anywhere you put it on the circumference of the circle, they're going to be all equal. So that is the concept behind this.